Okay, now here's your basic idea. Lambda is a constant multiple of the square root of r, and c is a constant multiple of r. Now what happens if you graph the square root of r, which looks like this, versus r? Well, also you know from calculus the derivative of the square root of r is 1 over 2 square root of r, right? So as r approaches 0, the slope here approaches infinity on this thing, whereas the slope here is constant. So you can conclude immediately that these graphs have to cross. Okay? No matter what multiple of the square root of r you use, and no matter what multiple of 2 pi r you use. In other words, no matter how big this slope is or how small this slope is, in comparison with the parameters of the square root function, you're going to have a point of intersection, right? Okay? So, there's always some number here where they meet. Okay? But that number is not necessarily an integer. Okay? This is C versus R, and this is lambda versus R. Okay? And when I say this is an integer, actually, it should be the reciprocal of an integer, right? Because lambda has to divide into C. Okay, so does that reasoning make sense to you? Okay, whatever the value of this and this, it creates for different values of our graph. Okay? So the graphs have to cross. And if you change R, well, yeah, we'll leave it at that. Because these graphs have to cross, we determine that there has to be at least one value of R where C is a multiple of lambda. Okay?